Finding the length of a chord segment is really just an application of the Pythagorean theorem. First, let's go over what a chord is. So a chord is any segment that stretches from one side of a circle to another side of the circle, like this red line here. That's a chord. Okay. A radius is half of a chord. If you extend the radius all the way to be a diameter, then we call that particular type of chord the diameter. Okay. Well, sometimes you don't want to find the whole length of a chord. Instead, what you want to find is just a segment of that chord, such as in this example where we just want to find out this particular little bit of the segment. Now, if you look at the problem for a minute, you might think, if only I could make a triangle right here, maybe I could use the Pythagorean theorem somehow, only I'm missing too many pieces of the puzzle. So we have to use information from other parts of the circle in order to derive that. And so it's a multi-step process. So let's take a look here at number 1 and see what we can piece together. Notice first that I am given the radius of this circle. I am given the radius of this circle, and that radius is 19.2. Okay, so what I can do first is I can extend this radius to the other side of the circle, just like this. Okay, because we know the radius is going to be the same wherever I draw it. If this is 19.2 right here, then this radius over here is also 19.2. Okay. Well, now I have a triangle, this little triangle right in here. I'm going to highlight it here. I have enough information to find out the missing side of this triangle, namely this point right here, which I'll call side A. I can find side A because I know that A squared plus B squared, okay, this is B in this little example, is going to equal C squared, which is 19.2. So we'll set the problem up and then we'll use a calculator to actually find the answer. And this is just the first part, because if I can find out what A is, I'll be able to subtract A from 19.2 and find out what X is. So that's kind of the process we're going to go through here. And that's what you'll do on all these problems. So let's again just set this up and remind ourselves that the Pythagorean theorem says that A squared plus B squared equals C squared. Well, I don't know A squared, okay, but I do know B is 17.2, so I can say plus, here we'll use a different color, plus 17.2 squared equals C squared, and I know what C is. C is 19.2, so I'll put in here 19.2 squared. Okay, so if I want to isolate A all by itself, which is exactly what I want to do, I can subtract 17.2 squared from both sides. And on the left side, these cancel out, and I'm left with A squared equals 19.2 squared minus 17.2 squared. Now, to get A by itself, I just take the square root of both sides. And that's the part we're going to do in the calculator. And that will isolate A by itself. So this part right here, this whole thing here, we're going to do in the calculator. The square root of 19.2 squared minus 17.2 squared. So let's pull up the calculator here. Give it a moment. And it should pop up here in a second. Okay, so we're going to put in here square root, which is second x squared, and then we're just going to put that in. That was 19.2 squared minus 17.2 squared. So just write 19.2 squared minus 17.2 squared. And just hit enter. 8.53229. I'm going to copy all of that down. 8.53229. Okay? So I'll end up rounding my final answer to the nearest tenth. But notice here that I have a now. Okay, it's like 8.5. And I have x right here. The sum of these two together is going to be equal to the radius, because this line, this vertical line right here that I'm highlighting in yellow, that's also a radius. So that yellow line is equal to this line right here. So the thought process is x equals 19.2 minus all of this, 8.53229. So let's go back to the calculator and just type in 19.2 minus the answer we got before, and we'll round that to the nearest tenth. Okay, so 10.66778084 rounded to the nearest tenth is 10.7. So my answer is approximately equal to 10.7, which would be letter A. And that is how you do these problems. Okay, so you're finding the segments of chord lengths. You'll notice that number 2 is very similar to number 1. And then if we look ahead, we have other information given. Okay, and so in number 3, the one thing that seems a little bit unclear when you start looking at 3 and 4 is that I think they're actually giving you the full diameter of the problem. So maybe we'll do one of these two here. Okay, so if the full diameter, in other words, this full chord length right here, is equal to 23.6, then the radius is just half of 23.6. So take 23.6, divide by 2, and you get 11.8. So that means that this radius right here is 11.8. And we'll probably need that information. So let's figure out what's going on. I have x. I want to know what that is. And I know that x plus whatever this value right here is has to be 11.8 because this is a radius. Okay, so that's kind of the thinking that's going into this. All right, so let's label some pieces here. If this was 11.8, then this right here, this hypotenuse, is also 11.8. Well, now suddenly for this little triangle, I have everything I need to apply the Pythagorean theorem and find out this value, which we'll call A. Okay, so this is A, this is equal to B, and this is equal to C. So we're just going to zoom in here and apply the Pythagorean theorem again. A squared plus B squared equals C squared. And we don't know A, so we have A squared plus, but we know B is 11, so it's 11 squared equals C squared, so that would be 11.8 squared. To get A by itself, I just subtract 11 squared from both sides. You might know that 11 squared is 121, but it doesn't matter you have a squared equals 11.8 squared minus 11 squared. To get a by itself, you simply take the square root of both sides. And remember, we're going to let the calculator do all this for us. So a is going to be equal to the square root of 11.8 squared minus 11 squared. So let's go back here and type in square root of 11.8 squared minus 11 squared. And that's 4.20813. That was 4.27083. All right. Good enough. And so if a is equal to 4.27803, then a plus x has to be equal to 11.8. Because remember, just like this is a radius, this is also a radius. These are equivalent. So that's why this is 11.8 and this is also 11.8. So here's what I can say. X is equal to 11.8 minus 4.27083. Back to the calculator. 11.8 minus that number gives us 7.52916 whatever. Rounded to the nearest tenth, it's 7.5. So we can say x is approximately equal to 7.5, which corresponds to letter choice B. Well, I hope this has been a good introduction for you to how to find chord segment lengths. And please make sure to reach out if you have any questions. Thank you so much for watching. Bye.